Alright, so on today's video we're going to talk about the Hotwire control using the KUKA Robot arm. So let's get started. So first thing you need to do is to open the Rhino file and then open Grasshopper, and then inside Grasshopper, if you have installed KUKA successfully, you should see the tab here on in the Grasshopper ribbon, and here you can see they have like 5 menu tabs. The first one is the core, where it contains the core and the movement method, and the other one contains the robot arms. So that's gonna be the KUKA robot that you wanna use or you have like in your place. The third one will be the menu about the tools, what kind of tool you wanna use for the robot arm. In our case, it's gonna be a custom tool, it's gonna be a Hotwire, and then the last one will be the toolpath utility, like the offset and the tool axis, some kind of controlling about it. And the fifth menu is about merging multiple movements. Maybe we don't get to that one, we don't have to go there. So first thing first is we need to set up the setting of our KUKA robot. So first thing, we want to start with the core. Always you need to start with the KUKAprc core. So in the core, it requires some input, and also it requires some pre-setting. So the first thing it asks is for the simulation slider. So you can get a slider from the home tab here. Let's get a slider that's gonna be for the simulation, and that's first thing. Let's make sure it starts from 0 to 1, and maybe, or let's make it 1 to 100. Alright, maximum 100, and then make it a integer. Yeah, I think that will be better. Alright, the next thing is gonna be the commands. So the next thing will be the command line, and this one probably we need to build in the end. The third one will be the tool. So what kind of tool you want to use. So the tools depend on the KUKA robot you have, what kind of tool you have hooked to your robot arm. So that's gonna be the tool you wanna look in here. So in my case, we are using a custom tool, which is this Hotwire. It's like 600 millimeter wide and almost like 500 millimeter the depth of the Hotwire. So you need to model your Hotwire with the details of the hook, like the connector to the robot arm. And the most important thing is you need to place your Hotwire on the 00 canvas and direct it in the Z direction. So the Z direction will be the vertical join to your robot arm. So if you have your robot arm here and I have my Hotwire, that Hotwire should be placed on the 00, so that when I connect it to the KUKA core, it's gonna directly locate the position of the Hotwire directly to the robot arm in the simulation in the canvas. So the first thing is to model your Hotwire, and the second thing is to make it a mesh. So basically the KUKA core only accepts mesh, so you cannot have a build, so it's always advised to have it as mesh. So let's type mesh and then let's import set one mesh. Let's import our mesh here. Oops, actually I have it in pieces. Alright, that's my mesh. So now I have my tool. How do I connect it to the tool? I need to customize it first. So let me go back to the KUKA Robot and then let me go to the tools here, and here I want to, since I am not using the built-in tools, I have my own custom tool. I need to use one of these two components. So I have two options. That's option 1. Option 2 is this tool here. Either one, it doesn't matter, you can choose wherever. I usually prefer using this tool here, so let me delete that tool. So you need to connect your tool to the custom tool here, and then we need to set it up. So you go to set tool. First you need to give it a number so that that number corresponds with your KUKA robot arm, and then you want to customize, you want to configure where your tool endpoint is. So basically in my Hotwire tool here, I need to find this point here, that point. Alright, so you need to calculate where that point XYZ is. So if you go to the in the perspective view, I need to know exactly where that endpoint is. So in my case I have already calculated, so I know that this point has 0x and then has 0y, and then in the Z it's actually 800, was it 79? Yeah, 879 millimeter. Alright, and we are gonna get to this later on. And then you connect your tool to the tools. So that's one finished. Next, you need to specify the robot we are using. Let me hide this layer here, we don't need it anymore. So how do we specify the robot arm? In my case we have this robot arm, KR30/60 HI robot. So I want to use this robot arm here, and I want to connect it to the robot here. And then this is the collision geometry, probably we don't need it. So the only thing remains is the KUKA command. So let me grab these down here, and it's gonna be the simulation, and it's okay. So let's start with the command. So the idea here is to create a command line for the robot arm to guide the robot arm to walk through this guideline. So for us, let's start here. So I have built a base. Basically, let's say this is the base we use in our robot arm. You can model your whatever base you want, and then I have this styrofoam that I want to cut in this movement, like this linear movement, using the Hotwire. So how do I do that? Let's say we have only let's say we have only one curve. Let me bring only one curve here. Let me hide these. So let's cut this styrofoam in half using this sine curve. So first thing first, let's make a curve. and let's import our curve here, set one curve, and then we wanna divide this curve into points. So we say divide curve. So that divide curve is actually, you can find it here in the divide. You can divide it in many ways. I want to divide it by count, so let's say 10. 10 is okay, probably let's put 5. Let's say we want to have only 5 points in the beginning, and then if it works then we can increase. Let me move this a little bit further. And after that I want to create a plane. So we can create an XY plane, for example. You can type XY and then you can get the XY plane. So we connect our point to this. Now you can see the planes here. So after we created the planes, we want to go to the KUKA Robot here, and then in the orient plane, we want to orient our plane here, orient plane. So what that one does is, that component, it's going to orient the plane of our robot arm tool with the planes we have here. So the robot arm itself has its own planes, and we want to match them with these planes. So you want to connect it here, and then the orient point can be, I've already set it up as this point. I'm going to explain what this point is later after we visualize the robot arm. And then you want to choose the movement you want to walk to, like moving from this point to this point and this point to this point. You have variety of movements. You can choose like axis movement, like circular movement, linear movement, point to point movement, or SP line. For me, I'm going to choose the linear movement. So the target as planes are these planes here, and now the command is ready to be connected to the KUKA command. So now if I connect it, now I can see the robot arm hooked to the tool and also ready to be cut, to cut the styrofoam. So as you can see, my tool here, the one we had before, is actually placed on the canvas here and is connected to the robot arm correctly in this joint. And you can see this point here. This is actually right. So now we have the robot arm ready to cut this Hotwire. Now let's simulate and see if it works or not. So let's run the simulation and see what happens. Nothing happens. You see why. Alright, it's actually not this problem, it's the problem is with the slider. Number slider, I need to bring this guy here. Yeah, you cannot get 0 to 100, actually it should be 0 to 1 and should be a floating number. So let's see how it works. Let's run the robot arm, and if you can see, the robot arm is carrying successfully, but the orientation of the tool is not right. So how do you do that? You have two options. Option one is you have already this plane of the tool. You either can rotate this using the tool here, or you can change this plane to match with these planes we have here. So you can use, instead of XY plane, you can use, for example, XZ plane. Let me try XZ plane. Let's cut and see what happens. Oh, it is cutting, but it's cutting it from the side. So what we need to do is use the YZ plane. Let's see what happens now. Oh, it's giving me an error. XY plane, and then I can rotate this 90 degrees, and let's see what happens. Oh, this one actually did not work. Alright, so let me try an XZ plane here, and I think it's gonna work this time. So now the robot arm is cutting the styrofoam successfully and is going home, but the problem is that the robot arm is actually going through the styrofoam while it's reaching its first point. Let me make it shaded, and yeah, we have a collision here. So how do we solve this collision? Is by using an offset. Where do we get the offset from? You have many options actually. You can either extend this line and make like a vertical line and then connect. Oops. Yeah, you can create like a vertical line here and then adding another one here and connect to this curve, and then assign and then join them and assign it to this curve. Or we can use the built-in offset component from the KUKA here. The KUKA already has a built-in offset. Here we have tangent offset, Cartesian offset. Let's try this one. They have like 2 or 3 offset options. So here are my KUKAprc commands, and here is this command. As you can see, it's now offsetted the first point, but I want to control this. Let me put 100 mm in the Z direction. Oh, it's not enough. Let's increase it to 1000. Let's see. Yeah, I think that's okay. Do you see this point here and here? These are the offset points. Let's simulate and see if it works. Right. So now that one worked, and everything is fine from the beginning to the end. So what is that point here, the one I talked about? Orient point. We set one point, which is this one. So what does that point do is, let me show you. It actually guides it orient the tool, like this joint here, it oriented toward this point. So if I move it, and cut, do you see how the Hotwire is trying to match with this point here? It's like it's grabbing the robot arm in a direction, and it's orienting, it's optimizing all of the joints to be oriented toward this point here. So it's always advised to have this point placed. I usually place it like in the top of my component, or sometimes you have this kind of red error where it says, oh, there is a reachability issue, so you can simply move it a little bit backward for the robot arm to cut smoothly without any problems. So let's simulate and see if it works. Yep, everything's fine. So after we successfully placed this, we have two more tasks to do. The first one is to remember where to place the styrofoam in the reality. The second is memorizing this configuration, and then we need to define the tool we had in the KUKA Robot and using the same configurations. So how do we export the KUKAprc KRL file? You simply go to the setting, and you don't need to do anything here. You can simply type in like a name, for example, I say Hotwire, and it should have no space, Hotwire, for example, 1, and you browse, and for example I want to put it in the desktop, and if I click OK and then hit apply and then exit, so now I have my file on my desktop. Let me show you the file. Where is it? Here. Oops, let me open it. So I have my Hotwire 1. So you simply take this file and you hook it to your robot arm and you run it, and it should simulate this movement here. So that's the how to set up the KUKA robot for the Hotwire cutting with one curve. In the next video, I think I'm going to create two curves where we can control the center lines. So stay tuned.